In this topic, we are multiplying and dividing rational expressions. Now remember, since rational expressions are essentially fractions with variables, we're going to start by talking about how to multiply regular fractions. Let's multiply two fractions together. Write the result in lowest terms. 77 divided by 39 times 9 divided by 11. Alright, now if you recall, when you multiply two fractions together, either you'll multiply first and then reduce, or you'll reduce first and then multiply. Let me show you both cases. Alrighty, the first case, we're going to multiply the fractions and then reduce. When we multiply fractions, remember, you need to multiply straight across. That is, you multiply the numerators, and then you multiply the denominators. So we're going to multiply straight across. We have 77 over 39 times 9 over 11. And we're first going to multiply 77 times 9, and 77 times 9 gives a, well, let me put it down for us here. 77 times 9 on the top, and then 39 times 11 on the bottom. And when we multiply straight across, that gives us 693. We'll got to do some scratch work on that, but I did it on the side already, not to take up too much time. And on the bottom, 39 times 11 is 429. Huge numbers. Oh, I don't like the sight of this. But in any case, so on the top we have 693. On the bottom we have 429. Now we can go about reducing. So we need to find numbers that divide into both of these and write these numbers, using a factor tree if you like, as a product of prime factors. Well, let's see. 3 goes into both of these numbers because if you add their digits, 3 goes into the sum of those sum of those digits. So let's see. 693 is actually 3 times, what's it? 3 times 231, I think. And you can check my work for me. And 429 is 3 times 143. And we can reduce farther. Let's see, because remember what we're doing now. We're simplifying. So we're looking for common factors in numerator and denominator. 11 goes into both of these. Now that one you might not see right away. You might have to do a little bit of work for that. So 11 goes into this. 11 times 21 is 231. Again, I did some scratch work to achieve this. 11 times 13 is 143. And we could break down 21 a little farther. 3 times 11 times 7 times 3, because 7 times 3 is 21, over 3 times 11 times 13. Phew! Alrighty, so we're reducing. That means anything common we're going to cancel and replace with 1. So 3 divided by 3 is equal to 1. 11 divided by 11 is equal to 1, nothing else. So we finish by multiplying this out here. 3 times 7 is 21 over 13. And that would be our final answer right here. 77 divided by 39 times 9 divided by 11. The fraction 77 over 39 times 9 elevenths. Phew, that was method 1. Now, this method can work effectively when these are small numbers, but as you can tell, when you get big numbers, when these products are large, going through the process of simplifying actually takes a bit of scratch work and a bit of thinking. And again, I didn't put the scratch work in. I just went straight across and told you. So it takes a little bit of time. I actually prefer the second method. In your worksheet, you actually see 3 methods. The second and the third one are combined. The middle method and the end method I combine into what I call the second method. So the first method was where we multiplied first and then reduced. The second method is the preferable one, especially once you start getting letters. And that is, you first want to reduce and then multiply across. So let's take our fractions again. 77 divided by 39. Multiplied by 9 divided by 11. And before we actually multiply, we want to reduce. So I want to look at 77 and think, what goes into 77? Well, 77 is actually 7 times 11, right? And 39, what goes into 39? 3. 3 goes into 39. 3 goes in there 13 times. So 39 is actually 3 times 13. Now how about 9? 9 can be broken up as 3 times 3. And 11, well, 11 is just 11 times 1. Now by breaking these up earlier, it's much simpler to see the common factors, or actually to see the factors and put them in prime factorization form. Now we see and we cancel things that are common from numerator and denominator. So I notice that I can cancel a 3 here and a 3 here. That leaves me with 1. Similarly, I can cancel 11s here and here. There's nothing else from numerator and denominator that can be canceled, so now we multiply straight across, now that we've finished our reducing. 7 times 1 times 1 times 3 gives me 21. 1 times 13 times 1 times 1 gives me 13. And voila, I get the same answer as I did using the first method. However, this one was a little simpler and a little easier. This is the method that I'm going to encourage us to employ when we're multiplying rational expressions. That is, we're going to take our rational expressions, we're going to factor them first into smaller factors, then we're going to cancel anything that's common from numerator and denominator, and then we're going to multiply across. All right, so let's get busy. Let me restate what I just discussed. To multiply rational expressions, the first thing we want to do is completely factor all the polynomials, both in the numerator and the denominator. Second, we want to cancel any factors that are shared between a numerator and a denominator. And then finally, we're going to multiply the remaining factors straight across, numerator times numerator, denominator times denominator, to get a single fraction. When dividing rational expressions, we're going to use the reciprocal to change the division problem into a multiplication problem, and then continue to follow the steps above. Let's quickly talk about the division of two fractions. Divide the following and write the answer in lowest terms. 18/25 divided by 33/30. In other words, 18 over 25 divided by 33 over 30. Now, how do we divide fractions? Do you remember? Well, to divide fractions, the first thing we do is we invert the second fraction. In other words, we take its reciprocal. And then we multiply the fractions like we normally multiply fractions. In our case, we're going to factor, cancel any common factors, and then multiply across. All right, so let's go through the steps with this example. We have 18 over 25 divided by 33 over 30. The first thing we have to do is we want to go ahead and we want to flip or invert the second fraction. Doing so, this gives us the following. 18 divided by 25, and then inverting the second fraction would give us 30 over 33. Now we proceed. Now we multiply. That is, we're going to factor first, then cancel any common factors from numerator and denominator, and then multiply across. So 18 over 25, we're going to factor this first. 18 is 9 times 2, or if we like, we can write that as 3 times 3 times 2. That's what 18 is equal to. And then we have 25. 25 is 5 times 5. Now we have 30 over 33, so let's look at 30 and break down 30. 30 is 6 times 5, and that can be written as 3 times 2 times 5. And 33, that's just 3 times 11. So we've broken these down into factors. Now we cancel any factors that are common or appear in numerator and denominator. I see 5s here and here, so I'm going to cancel those. I see a 3 here and here. I'm going to cancel those, or you could have canceled it across here. It doesn't matter. One from denominator, one from numerator. There's no more 5s to cancel. There's no more 11s. Actually, no 11s, period. So now we multiply across. 3 times 3 times 2, which is 18 times 2, which gives us 36 on the top. And 11 times 5 times 1 times 1, or 55 in the denominator. We box our answer and we're done. We've simplified as far as possible. 18/25 divided by 33/30 is equivalent to 36/55 when written in lowest terms. Let's now apply multiplication and division to rational expressions.